On September 3, 2025, the ZTZ-100's new generation main battle tank appeared on Tiananmen Square. Official promotions highlight its 1,500 horsepower hybrid power system, an impressive range of over 600 kilometers, and a top speed of 85 kilometers per hour on highways. However, experts who truly understand military technology and geopolitics have raised several key questions, which cut through the shiny surface of the cutting-edge claims. Why does this so-called next-generation tank abandon the world standard 125mm main gun in favor of a 105mm cannon, which was NATO's standard half a century ago? Why use an advanced unmanned turret, yet only have space for 3 crew members, even leading one soldier to be squished into a corner of the vehicle? Could this reveal fundamental flaws in the chassis design and space utilization? Why does the cockpit have 3 massive touchscreens, which could all black out at once, instead of a more practical, redundant design? Battery revolution or trap? As for the hybrid system, Beijing's answer is clear and loud. Because our battery technology has made revolutionary progress, and costs have dropped to levels the West cannot match. But is this really the optimal solution on the battlefield? The chemical properties of lithium batteries cause them to lose performance drastically in extreme temperatures and risk catching fire or exploding under high-impact shocks. The brutal reality of the Russia-Ukraine war shows that delicate electronic components are highly vulnerable in a battle zone. The ZTC-100's massive, fragile battery pack is far larger and more vulnerable than the radio equipment the Russian military frequently loses, meaning a single grenade could turn this new energy tank into an uncontrollable fireball. The touted range improvement seems almost like a joke. Based on data from the Russia-Ukraine war, the average lifespan of a tank from combat engagement to destruction or loss of combat effectiveness is only 72 hours. In this inferno-like environment, the difference between a 600-kilometer range and 400 kilometers is negligible, because the tank is likely to turn into a burning pile of scrap long before its first tank of fuel runs out. More ironically, the complex hybrid system drastically increases the nightmare of logistical maintenance. If a traditional diesel engine breaks down, experienced mechanics might be able to make field repairs. But if the battery pack, electronic control system, or motor fails, the entire power system could instantly collapse. On a battlefield far from the base, this means a higher rate of equipment failure and irreparable battle damage. So in the end, the hybrid-powered tank doesn't seem to have an advantage. Why then did the ZTZ-100 make this seemingly pointless choice? Because China's battery production capacity is surplus. In 2024, China sold 9.5 million electric vehicles, and the actual production capacity of power batteries surged past 1,200 gigawatt-hours, with over 400 gigawatt-hours of unused batteries sitting idle. This excess capacity is the result of local governments chasing GDP growth and businesses trying to collect subsidies, leaving behind a massive industrial legacy. At this point, the People's Liberation Army's procurement orders have become like the magic cure, a perfect outlet for digesting this deadly surplus capacity. It's fair to say that the hybrid power system in the ZTC-100 is not a military-driven technological innovation, but a solution born from the failure of national industrial policy. Its primary task isn't to win the next battle, but to provide a lifeline for those near-bankrupt battery factories. The government is using the defense budget, which should be used to create the strongest weapons, to subsidize the surplus industrial capacity. They're risking soldiers' lives to pay the price for failed economic policies. Thus, the hybrid system in the ZTZ-100 is a high-tech cover-up, woven with fine threads, designed to hide systemic economic imbalances. It indeed leverages China's scale advantage in the battery industry, but this advantage is more about capacity than real combat performance. The 105mm gun, technological setback. Now, all the military powers around the world are doing the same thing, making their cannon barrels thicker and their armor-piercing rounds longer. This is because they're all fully aware that modern tank armor technology is advancing rapidly, with composite armor, reactive armor, and active protection systems layered one on top of the other. Only larger caliber guns with stronger muzzle energy can ensure a one-shot kill on future battlefields. Germany's Black Panther KF-51 is equipped with a Rheinmetall 130 120mm smoothbore gun, claiming a 50% increase in lethality over the current 120mm guns. The French-German Future Ground Combat System is actively exploring a more radical 140mm caliber main gun. Russia's T-14 Armata, while still using a 125mm gun, was originally designed with the potential to upgrade to a 152mm heavy cannon. The U.S. M1A2 SEP V4 maintains a 120mm caliber, but countless larger caliber gun technology projects are secretly advancing behind the scenes. Clearly, the ZTZ-100's small 105mm gun is not leading the way. The official explanation is weak and unconvincing. The 105mm gun is sufficient, and with our latest special alloy armor-piercing rounds, it can penetrate any current main battle tank in the world. If it's truly sufficient, why are all the military powers pursuing larger calibers, regardless of cost? And engineers in Germany, France, the United States, and Russia all mistaken? The truth often lies hidden in corners that no one wants to mention. China has faced insurmountable technical bottlenecks with the high-performance automatic loaders and precision turret drive systems required for larger caliber guns. From the ZTZ-100's overly long turret tail structure, it's likely using a relatively primitive push-type semi-automatic loading system, a mature but outdated technology that can't accommodate the larger, heavier 125mm shells. Why not use a more advanced automatic loading system? The answer points directly to China's industrial weakness: precision manufacturing. High-end CNC machine tools, precision bearings, high-strength special gears, and high-performance hydraulic servo systems, which are the bones and nerves of modern advanced equipment, are precisely the areas where China has long depended on imports and struggled to keep up. Thus, the ZTZ-100 chose a compromise, using a technically mature, low-risk semi-automatic loading system paired with a 105mm gun, which, while mature, has insufficient firepower. The benefits are clear: low R&D risk, low manufacturing cost, and fast production speed. But the trade-off is a dramatic drop in firepower. Some may argue, but with the latest tungsten alloy armor-piercing rounds, the 105mm gun is just as powerful as the 125mm. However, the problem lies in this: in a large-scale, high-consumption war, it's impossible to equip thousands of tanks with the most expensive tungsten alloy rounds. Ultimately, the majority of the Army's tanks will be equipped with conventional ammunition. At that point, the 105mm's limited firepower will become painfully apparent. Therefore, the official claim is essentially an excuse for the incompetence and shortcomings in core technological areas. Even more ironically, although the ZTZ-100 carries the official name of the main battle tank, its 40-ton weight and 105mm cannon configuration would classify it more as a light tank or assault gun in any other nation's military classification. The reason it is forcibly labeled as a main battle tank is entirely for political propaganda purposes. Naming it a light tank would openly admit that China is still behind the West in its most critical main battle tank technologies. For a regime eager to showcase its great achievements in military modernization, such an admission is unacceptable. So the ZTZ-100 became a strange hybrid. It carries the title of a main battle tank but lacks the firepower of one. Glass cockpit, deadly temptation. Another feature heavily promoted by the official media as a highlight of the ZTZ-100 is its highly integrated glass cockpit, as if Tesla's cockpit were directly transplanted into the tank. However, in the eyes of real tank designers and soldiers who have been through the crucible of combat, this design is an extremely dangerous, even foolish, step backward. It exposes the designer's ignorance of the harsh battlefield environment, and their ignorance in disregarding the soldiers' lives in order to cut costs and create a false sense of high-tech innovation. Tanks like Germany's Leopard 2 or America's M1A4 are filled with what might seem like outdated physical buttons, levers, and knobs. These are the results of invaluable experience gained from countless real battles, often paid for with blood. On the battlefield, tanks are constantly at risk of severe impact, shrapnel, or even EMP attacks. That's why physical isolation and functional redundancy are essential. The driving, fire control, and targeting systems are physically and electronically independent. Even if the fire control computer is destroyed, the gunner can still perform rough shooting with a hand-cranked joystick and backup optical sights. Even if the power system is damaged, the driver can still rely on basic mechanical instruments to assess the vehicle status. In contrast, the ZTZ-100's highly integrated glass cockpit means that a single shrapnel hit, a short circuit, or even an unprecedented software bug could cause all three screens to go black, instantly turning the tank into a deaf and blind steel coffin. Imagine being a soldier, wearing thick fireproof gloves, trying to make precise adjustments on a smooth touchscreen inside a tank speeding across rough terrain at 60 kilometers per hour. You're shaking violently, and explosions are ringing in your ears. Physical buttons, on the other hand, provide clear tactical feedback, allowing soldiers to rely on muscle memory and operate blindly in the dark and chaos. A touchscreen becomes almost useless when covered in mud, rain, or even blood. Military-grade electronic components must undergo extremely stringent tests, including extreme temperatures, intense vibrations, and electromagnetic compatibility. These components cost tens or even hundreds of times more than civilian-grade products. The large, bright displays in the ZTC-100's cockpit are likely supplied by China's massive consumer electronics industry. The advantage of this approach is that costs are kept extremely low, and the supply chain is fully self-controlled. But the downside is that these fragile screens, designed for civilian cars or tablets, simply cannot withstand the harsh tests of the battlefield. Therefore, the ZTZ-100's glass cockpit is not a true technological innovation, but yet another compromise, where costs come first. It's a shortcut taken by the designers, using China's mature consumer electronics industry to avoid addressing the technical shortcomings. A three-man cage, the chassis curse. The ZTZ-100 uses an unmanned turret, which reduces the crew to 3 members: the commander, the gunner, and the driver. In theory, this should improve crew protection. However, from images of another vehicle based on the same chassis, a fire support vehicle shown during the parade, it's clear that the 3 crew members are cramped side by side in the narrow vehicle interior. One soldier is almost face to wall, with very limited space to operate, and with poor visibility. This seemingly minor detail reveals a deeper structural flaw in the ZTZ-100's design philosophy: the blind worship of the universal chassis concept. Using the same chassis for different modules has resulted in a chassis that's not large enough and not optimized for the tank's needs. The universal chassis, which is used across main battle tanks, infantry fighting vehicles, self-propelled artillery, and support vehicles, is heavily promoted by the U.S. FCS program. It aims to simplify logistics, reduce lifecycle costs, and speed up production. It sounds great and fits well with China's obsession with focusing resources on big projects and mass production. The ZTC-100's design is clearly a product of this concept. However, the U.S. eventually abandoned the program because, in practice, they found that the price of Universal was mediocre. Different types of military vehicles have drastically different and even contradictory requirements for their chassis. A main battle tank needs to be as low as possible to minimize the target area, with the thickest armor focused on the front. An infantry fighting vehicle needs the ample internal space to carry an infantry squad. Self-propelled artillery requires a chassis that can withstand immense recoil. When one chassis is used to meet all of these needs, the result is inevitably a jack-of-all-trades, master of none. The poorly designed crew compartment in the ZTC-100 is likely a direct consequence of this compromise. The chassis may have initially been designed with more space in mind, perhaps for an infantry fighting vehicle or universal platform, and wasn't specifically optimized for a main battle tank's 3 crew members. The side-by-side layout not only makes the vehicle wider, increasing the likelihood of being hit, but also makes it difficult for the crew to collaborate, share information, and escape quickly in an emergency. The underlying logic behind this design choice is the same familiar one. The priority is not making the tank more deadly or survivable on the battlefield, but making it easier to produce and maintain in the rear factories. Soldier combat efficiency, battlefield awareness, and even survival chances are sacrificed in favor of industrial convenience and cost savings. This leads us back to the haunting conclusion: the design of the ZTC-100 is deeply constrained by the mentality that quantity and cost overrides everything. The hidden truth, politics, and economics. Now let's step away from the technical details and examine the deeper question. Why is the ZTZ-100 in its current form? The answer lies in the need to utilize China's surplus production capacity. Industries like EVs, photovoltaics, and lithium batteries, which were created through state-driven initiatives, have massive subsidies from both the central and local governments. As a result, China now has excessive production capacities that can't be absorbed. For example, CATL's factories operates at less than 60% capacity, and BYD has started indirect layoffs. What to do? If civilian vehicles aren't selling, the military still has money to buy vehicles. After all, there's defense funding. So why not see if military vehicles can use these batteries? Given the oil shortages in China, they came up with a ZTZ-100 hybrid power system, with each vehicle requiring about 50 to 80 kilowatt-hours of battery power. If the plan is to produce 5,000 vehicles, this would create a massive demand of 250,000 to 400,000 kilowatt-hours. This is enough to keep several nearly idle battery production lines running at full capacity for a year. The same logic applies to the steel factories that provide the materials for the tanks, the electronics manufacturers that supply the displays, and countless local state-owned enterprises that depend on this industrial chain. The ZTZ-100 thus becomes the perfect capacity digester. Next, we have the systemic problems within China's industrial military complex. China's military enterprises are not purely market-driven entities. They're state-owned enterprises burdened with heavy political tasks. Their performance evaluations, beyond profit, focus more on maintaining employment, achieving technical autonomy, and supporting related industries. In this rigid system, cost control and political stability take precedent over the ultimate pursuit of weapon performance. If a conscientious designer suggests to upgrade to a 125mm gun, use multi-screen displays, and increase armor thickness, the answer they're likely to receive is no. What we need is something that could be mass-produced, priced within control, and can drive the entire industrial chain. As long as performance is sufficient, it's fine, as long as it looks advanced in a parade. Thus, the ZTZ-100 becomes the compromise we see today, a product carefully twisted and shaped under the constraints of politics, economics, and technology. Finally, there's the narrative need, serving both domestic and foreign policy. Domestically, the Chinese Communist Party needs to showcase historical achievements to legitimize its leadership and spark national pride. Internationally, it needs to present a strong stance to the world, especially potential adversaries. In this context, the actual combat effectiveness of the ZTZ-100 becomes secondary, while its symbolic value is raised to an extreme level. However, when it is actually deployed on the battlefield, all compromises hidden by propaganda would be ruthlessly exposed by the first barrage of fire. At that point, the grand narrative of being world-leading will instantly shatter. War is the harshest test of weapons and national strength, and the ZTZ-100 has yet to undergo the test. Maybe it never will if it's lucky enough.